Hi, good day. You're welcome to our organic class. Here we're starting a fresh class, basically organic chemistry. And what we'll be discussing, we'll be looking at the introduction aspect of organic chemistry. And looking at the introduction aspects, what are we looking at? We look at what organic chemistry is. On a neutral ground, what is organic chemistry? When you talk about organic chemistry, all what is dancing around is just talking about chemistry of carbon. Is in a nutshell, organic chemistry is just a branch of chemistry that studies carbon-containing compound, focusing on specific things. What are those things? We talked about the structural arrangement. You talked about the properties of those compounds, the preparation method. Then you talked about the reaction they undergo and the uses of these compounds. While we're looking at organic chemistry, let me just give you a brief information about that. When you look at the pharmaceutical industry, that is drug synthesis, drug production, you will see that most of the activity there is powered or is surrounded by organic source, that is organic chemistry. So it deals with study of organic chemistry. That is one thing as a pharmacist you need it. Then apart from that, industrial chemists talked about synthesis and some other things such as generating polymers and some other things. You dive into polymers, dive into different area of science precisely. You will see that organic chemistry is highly important. So let's look at a brief information. What history do we have concerning organic chemistry? That is what will lead us to the this particular slide. Let's look at a brief history, that is historical background of organic chemistry. Initially, what they believe is that organic chemistry only has something to do with living organisms, that organic compound are only synthesized. That is, organic compound come originally from what? From organic source, that is a living organism, of which this particular one was backed up by a theory regarded as what? Vital force theory. That is what said that living organisms are the major source of organic compounds. So that is it. Then in the year 1828, there is a particular breakthrough by a good scientist. The scientist was just working in the lab, dancing around chemicals and trying to work on a particular chemical. And actually, in a nutshell, he was able to discover something very interesting. What is that thing? That is the synthesis of urea, which nullify and destroy our initial belief, which has something to do with the vital force theory. And this was actually established, was actually affirmed, was actually discovered by Friedrich Wöhler. He was the one that brought about this breakthrough. That's the reason why we study organic chemistry at life. Today we have different forms of organic chemistry, aspect of organic chemistry. We have what you call natural product, we have what you call synthetic organic chemistry. Now let's go about this. Then this particular discovery actually paved way, opened doors for the latest and current modern organic chemistry that does. I believe you are joining. I believe you are following. Thank you very much. So let's look at, when you now talk about organic chemistry, there is a need for us to understand something. We have to classify them. Let's talk about the classification of organic compound. That is what classification do we have? We want to classify organic compound on a neutral ground. Organic compounds are classified in different ways. You can classify them in different ways. But here we are going to be stereotyped based on classification, based on chain arrangements, based on collected diagram information. That's what we want to base our classification on. And what is that classification? What are we talking about? We are talking about what? Classification based on chain structure. So here we were talking about something related to aliphatic and aromatic. When you talk about the word aliphatic, that is, we are talking about not resonance organic compound, not resonating organic compound. That is organic compound that doesn't have resonating pi bonds. So when we get to that, we'll discuss more on that. But currently, let's look at it. The aliphatic that we are talking about, they are actually classified into two. We have what we call the open chain, which is also called what? That is a cyclic organic compound. And we have the other one, which is called cyclic or alicyclic organic compound. This one, they are what? They are ring shaped in nature. But the first one, the former, which is what? As cyclic, was what? That one was what? A straight line, an open chain organic compound. So, but the second one is what? A ring shape, but a close ring, that is skeletal. Just do your hand like this. You can see making love like this. This is what we are talking about. This one is cyclic. And if you have it this way, going like this, there is no point of convergence between them. Then you said you have what? A cyclic. But in a scenario whereby you now have a resonating, whereby this particular part, if this part is the same thing as long as this, and this one is as long as this, everything you can definitely dance around them. Then you said you have a resonating. That is what we called aromatic organic compound. They are also called arenes. Anyway, so let's move ahead. Let's look at an example of this compound that we are talking about. The first one, you can see is cyclic there. You can see it on the screen. Then apart from that, you can also see alicyclic. These are alicyclic, like when we talk about alkenes. They are examples. But you can have them in a cyclic form, like this cycloalkane, such as cyclohexane, cyclopropane, cyclobutane, cyclonone, cyclo. So far it is an alkane or alkene, definitely. We regard them as what? Alicyclic or cyclic organic compounds. So they are classified under that. Then we have other example of what? These ones are aromatic. I'm sorry, I think I have an edit to make here. So it's an example, these are example of aromatic organic compounds, not aliphatic. Take a note of that. Aromatic organic compound. Example there you can say benzene. These are benzene family. Not only benzene family, you can have even other resonating organic ring, but on this basis we'll be talking about benzene in most cases. You can have substituted benzene when you have other things attached to it. Then you can have what you call ethylene, you have xylene, toluene, and so on and so forth. Then depends on the substitute. You can have nitrobenzene, you can have aniline, you can have aniline is when you have NH2, that is an amine group being attached to it. Take note of that. Then you can have what you call phenol, which is OH group attached to it. Then you can also have it in a polyaromatic format, such as what you have there. You can see this example. This is one of the example of that. You have aromatic, which is this one is naphthalene. You can see naphthalene there on the screen. Then, and apart from that, you can see, what do you call it? Anthracene. Then you can have phenanthracene, you can have benzoylpyrene, you can have pyrene, you can have and so on and so forth. There are many. You have a lot of what? Polyaromatic organic compounds. Now let's look at this one. After considering, looking at different organic compounds that we have, different forms that we have, then I think there is a need to now be able, we can now talk about different, a family name for all of them. But before we talk about for that family name, there is a particular terminology that defines how we can classify. Let's look at it. That is homologous series. What is the meaning of homologous series? The term homologous series is talking about a family of organic compounds that have the same, what they have in common is that they have the same functional group. They are functional in nature. They have the same functional group, similar chemical properties, and a general formula that relate them together, of which all of them conform to. Then the only thing you notice about them is that successive member only differ by CH2. That is one thing, which is methylene group. Take note of that CH2 attachment, which distinguish them. Now, apart from that, what are the characteristics of homologous series? At least from the definition and the information I've given you, you understand that. Can you give me one? I think you should be able to do that. They have the same what? General formula, functional group, similar chemical reaction in nature, the physical properties increases or differs as the number of carbon atom increases. Understand that. Then the successive member differ by what? CH2. Thank you. You are funny. Then in a similar method, they have similar method of preparation. So let's look at the next slide, which give us some example of homologous series. I think we will end it there. By the time we look at that, we are done with that. Homologous series, different types. You can see the alkanes. What is the functional characteristic? Functional group? Just a single bond. Alkanes, you have double bond equivalent. Alkyne, you have triple bond. Take note down to only that. Then you have haloalkane. All those haloalkane. Halo means halogen group being attached to an alkene group. So which means you are going to have halogen. Give me an example of halogen: chlorine, fluorine, bromine, iodine, etc. Those are halogen group 7 elements. So when they are attached to alkane, then we call them haloalkanes. So that's the reason why you see that X representing an haloalkane group. Thank you. Now look at alcohol. You have OH, that is this symbolic representation for alcohol. OH, anywhere you see OH, just note that is an alcohol, or you call them alkanol. Then you have ether. Ether is what? O in between, then you have a bond associating it. On the neutral ground, you can see the rest and so on and so forth like that. Ester, COO, then you can have R, you can have a metal in front, which can give you either alkyl ester. You understand that? So it depends on the kind of alkyl you have. Thank you very much. I think you understand the lecture, you enjoyed the lecture. If you enjoyed it, can you just give us a kind of thumbs up? And if you need more assistance, then you can reach out to us. Thank you very much. I'm always available to be your teacher, to be your tutor, I'm always available, definitely regularly available to be there for you. Thank you very much, and God bless.